Okay, so now that we have the recording, please type your name into the chat so that we have your records so you can receive data for the next session. Anything that you wrote in the chat before the recording started gets deleted. So please make sure that you type your name in now since I started the recording. Um, okay, I'm glad everybody's joined. I hope a few more people will join in a little bit. Um, I want to give a couple of administrative updates. So the first is that I'm going to be making the certificates this week and giving them to Mr. Randolph on Tuesday for next week. I think there's a delegation from Liberia in New York right now, and Mr. Randolph's going to try to get it to somebody so that they can carry the certificates to Liberia. But I'm going to be making them this week. I already sent out all the names and I got a few corrections. If you still need to make a correction or if your name's not on the list, I think everybody's name here is on the list. So if your name is on the list and you think you should be included for a certificate, please send a chat to the room so that I have a full list because I'm going to be doing all of them this week so that they can be carried next week. So hopefully we can get all of the certificates to you by the end of the workshop, by the end of the program. Okay, so second reminder, which I think some of you know, is that the Wits mathematics competition is going to take place in 2 weeks. I don't know if a date has been chosen yet for Monrovia or for Ganta, but I think Devora or Mr. Bropla or Sanjay or somebody will tell you exactly what date it's supposed to be taken. As it is now, we're going to spend a little bit more time discussing it today because we didn't get to finish all of the problems from last time, and I think that's going to be the best use of time before we move on to other things to conclude the workshop. So let me just remind everybody what this WITS math competition is. Right, it's an annual written math competition done at the University of Witwatersrand, which is just WITS for short in South Africa. So I'll call this just WITS. That's what they usually call it. And it's taken place every year since 2018, and Liberia has participated since 2022. And it will happen the qualifying round, which is the first round, will take place between May 11th and May 17th. And students who do particularly well in the qualifying round will advance to a second round in September. And I think the first or second year that Liberia participated, there was a student, I believe from Monrovia, who did well enough to advance to the second round. I've forgotten his name at this point. Let me actually see if I can look it up. WMC. If I can find his name back in my email. Let's see. All right, well, I can't find it now. Okay, I can't find it now, but at some point, I'll try to remember the name so that I can. Montel Reeves. That was his name. His name was Montel Reeves, and I don't remember what school he went to. Um, so,
But
but I think
Antwerp,
Kaito was what school?
JJ Roberts,
JJ
Antwerp Street,
Roberts.
Single.
Okay,
Yeah.
in Syncor. Okay. So he did well enough to go to the second round, and he and his coach both got a prize for that. So we're hoping that somebody will be able to do that again this year. Okay. Hi, Sanjay. Uh, how are you? Okay. So there's more information here on the website. I'm not going to go to the website again. Most of you saw it last time. Okay. Okay, so there's 20 multiple choice questions with 5 answer choices each. I didn't dwell on the multiple choice aspect of this so much last time, but I'm going to spend more time on it today because sometimes the question being multiple choice can help you or can help your student get the answer correct. So I'm going to talk a little bit more about the choices today. And so the easier questions are worth 3 points, and then they go up to 4, 5, or 6 points for a total of 90 points. And 75 minutes are allowed to write the exam, no calculators, and the material needed is basic high school material, but the questions can be difficult. They can be fairly tricky. I guess actually, Sanjay, what do we know what dates the exam is going to be given?
Yes, the exam is scheduled from the 11th to the 17th, but they will be giving the Ganta on the 12th. I mean, Ganta and Monterrey will be on the 12th.
Okay, on the 12th. Okay, great.
Yeah,
So
but it
that's
starts on the
Tuesday.
11th.
Okay. So
Mm.
Tuesday the 12th. Okay, great. And in particular, you don't need to know calculus, you don't need to know vectors, you don't need to know bearings, you don't need to know, you barely need to know any trigonometry. The actual math you need to know is mostly at a lower level, but you need to use it creatively. And so we're gonna, get a little bit more exposure to the types of questions that show up. Okay. So, what kind of math to expect? This is just a slide from last time. Remember, we saw there were 4 questions on geometry, 2 questions on statistics and probability, 6 questions on arithmetic, 7 on algebra, and 1 miscellaneous question. And this is, won't always be exactly like that, but this is fairly representative of the contest in general. Maybe I'll just say sometimes there are more probability questions. Okay. So, okay. So I want to actually, we did a bunch of questions last time. I want to go over a few more of these, and then we're going to try to distill a few strategies that are the most effective strategies. If you have very limited time to coach your students, maybe you only have one session, then these are the strategies that I think are the best to teach your students because they're what seems to show up the most. And yeah, they seem to show up the most, and they're going to pay the greatest dividends for a short amount of study time. So, first, I want to just do 3 more questions from last time. These are the ones that I had written down, and then these are the ones we didn't get to finish, and then talk a little bit about general strategy. Okay, so the first question is question 11 from the 2022 competition. So it says compute this product 1 minus 1 over 2 squared times 1 minus 1 over 3 squared, all the way up to 1 minus 1 over 2021 squared, and then 1 minus 1 over 2022 squared. So this is one of these long computations, and clearly the answer is what do you not do? Do not just do the computation. Okay? It's too long. You're gonna get it wrong, right? You're never gonna get it right. It's gonna take forever and you're gonna make mistakes. There's just no way to do this by actually multiplying everything out. So what you do want to do for all of these is look for a shortcut or a rearrangement. Okay? So how do we do a shortcut or a rearrangement? So you want to look to see if there's any identities. So there's a reason that all of these terms look like this, right? 1 minus 1 over 2 squared, 1 minus 1 over 3 squared, and so on. There's usually a way to rewrite these that's going to make it look a little simpler. Okay? Because ultimately, the only way you're going to be able to evaluate this is by having some kind of cancellation happen, right? Because without cancellation, this is just going to be too hard to do. So, does anybody see a way to rewrite these terms that might make it easier to see some cancellation here? Okay. Well, I'm going to write something here. Doesn't change anything, but maybe it gives you a hint. Instead of 1 right here, I'm going to write 1 squared. And here I'm going to write 1 squared, 1 squared, 1 squared. Right? It's the same thing, right? I'm allowed to square 1. It's still just 1. Makes no difference. And then instead of 1 over 2 squared, I'm going to write this. I'm going to write 1/2 squared. Sorry. And here I'm going to write 1/3 squared. Sorry, squared. 1/3 squared. And then 1 over 2021 squared and 1 over 2022 squared, right? I haven't changed anything. I've just rewritten this so that every term here is a difference of 2 squares. So 1 squared minus 1/2 squared, 1 squared minus 1/3 squared, 1 squared minus 1 over 2021 squared, 1 squared minus 1 over 2022 squared. So when you see it written like that, what does it make you want to do? What's a way that you can rewrite these expressions in a way that might let you simplify things? Anyone?
Yes.
Yes, Princeton.
Yeah, so if we written this, if we have the square of 1, it will give you 1.
Mm-hmm.
And then if we take in the half of the 2, will be 1 over 4.
Mm-hmm.
So we get 1 over 1 minus 1 over 4 for the first permittancy.
Sure. Okay, so that's just evaluating it, right? So if you do that, you'll get 1 over 1 minus 1 over 4. And if you evaluate that, you're going to get 3 over 4. And if you do something similar here, you're going to get 8 over 9. And if you do something similar here, you're going to get, I don't know, uh, 2021 squared minus 1 over 2021 squared. So you can do it, it's correct, but it's not clear that it makes it better. So, okay, so James has an answer. So he says, are you using difference of square formula? And I think the answer is, let's try it. It might make this look better, because otherwise we have no idea what to do. So let's use the difference of square formula. Remember, the difference of square formula is that anytime you have a squared minus b squared, that's equal to a minus b times a plus b, right? This is a formula. It's a formula that's often very, very useful in these types of computations. A squared minus b squared is a minus b times a plus b. So here we have a whole bunch of things that are of the form a squared minus b squared, a squared minus b squared, a squared minus b squared. So let's see what happens when we apply the difference of squares formula. So instead of 1 squared, so applying the formula, what do we have? Well, instead of 1 squared minus 1/2 squared, I have 1 minus 1/2 times 1 plus 1/2. And then instead of 1 squared minus 1/3 squared, I have 1 minus 1/3 times 1 plus 1/3. And then so on. And then here I have 1 minus 1 over 2021 times 1 plus 1 over 2021. And then lastly, 1 minus 1 over 2022 times 1 plus 1 over 2022. Okay. All right, that doesn't necessarily look better yet, but let's actually write these out. So what is 1 minus 1/2, right? Remember, this 1 over here is the same as 2 over 2. So I'm not going to write out the intermediate steps because I don't have a lot of space, but 1 minus 1/2 is 1/2. 1 plus 1/2 is 1/2. 1 minus 1/3 is 2/3. 1 plus 1/3 is 4/3. And then maybe I'll write out one more term. I have 1 minus, let me write out one more term. So 1 minus 1/4, 1 plus 1/4, dot, dot, dot. So what do we have here? So 1 minus 1/4 is 3/4, and 1 plus 1/4 is 5/4. And then dot, dot, dot. This goes all the way over to 2020 over 2021 times 2022 over 2021, right? That this is 1 minus 1 over 2021 is 2020 over 2021. 1 plus 1 over 2021 is 2022 over 2021. And then same thing for the last ones. We'll get 2021 over 2022. And then lastly, 2023 over 2022. Sorry, 2022. Okay. Oh, sorry, 1/2 times. This is 3/2. Okay. All right. So now what should we observe? Well, if you look at this, we can observe that we're going to get some cancellation here, right? What cancels here? Well, I have 3/2 and I have 2/3. And then I have 4/3 and I have 3/4. That's going to cancel. And here I have 5/4, and the next term is going to be 1 minus a fifth, which is 4/5. That's going to keep canceling out. So it seems like we've cancel, 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 and then 2022 over 2021 times 2021 over 2022, right? So it looks like we've got everything canceling. This cancels. The 5/4 is going to cancel with the 4/5. There's going to be a 4/5 term next. Dot, dot, dot. Then there's going to be a 2021 over 2020 that's going to cancel here. You see the pattern is that everything is going to cancel except we have a factor at the beginning that doesn't cancel and a factor at the end that doesn't cancel. Right. So James has exactly the right answer. Right? Because we have this cancellation, and that's because we wrote it out this way, what we're left with is only these two terms, 1/2 and 2023 over 2022. So we end up getting 1/2 times 2023 over 2022, and that's equal to 2023 over 4,044. Okay. And so that's the final answer here, right? And there's what am I going to say? Sorry, no possible way of really doing this any other way. You have to just find this cancellation by doing this rewriting, because to try to evaluate any other way, you're not going to see the cancellation. And without the cancellation, you have no chance to actually get the problem right. Okay, so for these arithmetic problems, a very common strategy is they give you some long-looking computation. And it's too hard to just do it directly. You have to find a trick. You have to find some way to rewrite it so that the computation becomes easy. And one very frequent way of doing it is to use this difference of squares formula, a squared minus b squared. Because once you do that and write out all the terms, you start to see everything that I'm going to just circle the terms that cancel, right? 3/2 times 2/3, 4/3 times 3/4, 5/4 times 4/5, and then everything up to here, this cancels, and then there's also a term here that I didn't write that cancels. Okay, so this is how to evaluate this. Comes out to be 2023 over 4044. So you definitely don't want to spend time trying to do it a hard way. One thing you can tell your students is that if they work a few minutes on a problem and they can't figure it out, then they should skip it and go to the next one. Okay, because they can lose all of their time on one problem and it's not worth doing. It's better to skip it and then come back to it. Just make sure that when they fill in answers that they're answering the correct problems. Okay, any questions on this example?
Yes, I have a concern
Yes, Princeton.
when it comes to the 1/4 where we added on this problem.
Yeah.
We already justified this problem here. We got one, we got half, we get 3/2, we get 2/3, and then we got 4/3, and then we get 3/4. Well, we couldn't just stop here because the cancellation will always show here. Instead of we going to 4/5,
Yeah, I just showed a little more to make the cancellation clearer. You can stop if you want. I mean, once you see the cancellation, you don't have to write out any more terms. I just wrote out an extra term to show the cancellation.
Okay, sir. Thank you.
Yeah, it's just for clarity. All right, other questions? Okay. All right. Okay. Let's move on to the next. So we didn't do any geometry questions last time. So I want to show the geometry questions. Oh, and I realize I didn't draw this. Okay, so I actually need to find this. problem on the Wits math page. So let me look here, past papers. Okay, senior secondary qualifying round. Okay, so this is question 6. Okay, so a sequence of squares is drawn, each square having a side on the line AB. A path is drawn indicated by the arrows, and the path is 96 meters long. Calculate the length of AB. So I'm going to draw this. This is A, this is B, and it's going to go like this. Okay. Okay. So this is the path, and I'm going to call this B, actually. Let me just erase this over here. Okay, and so that the path just has some arrows. It just tells you which way it's traversed. Um, okay, and so the question is how long? So if the path is 96 meters long, then how long is the line segment from A to B? And the idea and the other key piece of information is that everything drawn here is a square. Okay. So if you take this entire path down and up and down and up and down and up, take the entire square, everything is 96 meters total. So the question is, how can you relate the length of AB to this entire path using the fact that everything is a square? And so I should say, the geometry questions don't use complicated formulas. They use only the basic formulas for circles, triangles, and rectangles, but they can be a little bit tricky to set up. Okay? So this is one of these examples. The only thing it's going to use is the perimeter of a square, 4 times the side length. But figuring out exactly how to do it maybe takes a little bit of thought. So maybe we can take a minute to think about this. And then if anybody has any ideas for how to approach this, I'd be interested to hear them.
Yes.
Yes. Princeton.
Looking at this diagram, let's assume that we have the size of this diagram to be like 3.
Mm-hmm.
And looking at the size of the diagram to be the 3, which if we set it, it would be s plus x plus s, which will give us 3x.
Mm-hmm.
That is the size of the diagram,
So
3s.
the side for
Now,
each
in
square, you've
mathematics,
got 3 sides
yes,
that you're traversing, right?
yes,
Mm-hmm.
yes. So it will be 3s. So mathematically, we will have 96, which will be equal to the meter,
Mm-hmm.
3 times AB, that is the length.
Yep.
So now we get 96 will be equal to 3 times AB will be equal to 3AB. And then if we divide both sides by 3,
Mm-hmm.
you get 32 meter for AB.
All right, that's perfect. So that's exactly correct. This is written South African, so it's usually British spelling conventions. Um, yeah, so that's exactly right. So 32 meters. So I want to dwell a little bit more on how we set up this equation. So we're saying that the length of this path is 3 times the length of AB, right? So can you explain just a little bit more how we know that? How do we know that the length of the path is 3 times the length of the line segment AB? So it's correct. I mean, you're correct. This is the right answer. So I'm just asking, how did you know? How did you know that 96 is 3 times AB? All right. Well, look at these sides
Yes.
of the square. Yes, sorry, Princeton. Yeah.
So looking at this problem
Hmm.
of the two-sides of the length, it tells us that if the transverse of the left side is half the transverse of the left side, also the top side, and
Hmm.
consider at the right side of each square, then the length for each square will be equal to 3x.
Right. Right. So each square path is 3x, but the part along AB is x, right? Yeah. So that's exactly right, right? For each square, you're going to go on 3 sides. That's 3x, but along AB is only x on that square. So that means if you do the whole path, you're going 3 times as long as how long you do as if you went directly from A to B. Great, that's perfect. And in order to answer this question, we don't need to know how big the individual squares are, right? It's good enough to just know that the whole path is 96 meters long. Okay, so that's perfect. That's how we set it up. The path does 3 sides for every side along AB, and so that means the whole path will be 3 times as long as AB. Okay, great. And so that means the length of AB is going to be 32 meters. Okay, so I'm going to say this here is the full path. Okay, so the full path 96 is 3 times AB. Okay. All right, great. Any questions on this? Okay, great. So again, not using anything complicated, just the side length of a square and simple algebra, but you've got to see it. You've got to realize that your path is going 3 times as long as the length of A to B. Okay, the three, so Harrison asks, how do we get the three? The three is because we've got 3 sides of each square is our path. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. But the actual length from A to B only has 1 side of each square. So for every 3 sides that we do, the path from A to B only does 1 side. So that shows that our distance is 3 times as much as the distance going directly from A to B. 3 times as much here, 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 and 3 times as much here. Is that okay? Yeah, so it's 3 sides versus 1 side. That's how we get the 3. 3 times as long. Okay, let's move on. Okay, so another question. So ABCD is a rectangle. Point E lies on AB such that angle DEC is 90 degrees, DC is square root of 10 centimeters, and DE is 3 centimeters. Find the area of ABCD. So you look at a question like this, absolutely no way that you can do this without drawing a picture. So when you have geometry, if they don't give you a picture, you need to draw your own. So always draw a picture. Right, so I'm going to draw my rectangle ABCD. Okay, that's my rectangle. Maybe I'll call it maybe I'll call it A, B, C, D. And now point E lies on AB. So I'll call this point over here point E, such that angle DEC is 90 degrees. So I'm going to draw that angle. I'll draw a line from D to E, then I'll draw a line from E to C, and this should be a right angle, right? 90 degrees. And then at the same time, so DC is square root of 10 centimeters. So I'll label that as square root of 10. And DE here is 3 centimeters. And the question is to find the area of the entire rectangle ABCD. Okay, so there are a few different ways of doing this. I think one way is the best. And none of them requires anything beyond the basic geometry formulas. Area of a triangle, area of a rectangle, Pythagoras theorem, right? We're not using any serious trigonometry or anything like that. Most of these questions can be answered with basic math, okay? You just have to use it creatively. So it's asking for the area of a rectangle, but we're drawing a triangle inside the rectangle, right? And so one thing, so yes, first draw a picture. Other thing is then we can observe how is the area of the triangle related to the area of the rectangle. Yeah, so the first step of these, always draw a picture. Well, we know when we draw a triangle inside a rectangle like this, right, that the area of the triangle is half the area of the rectangle, right? Area of the triangle is half the area of the rectangle, right? Because the rectangle is base times height, but the triangle is 1/2 base times height, right? So if it's asking us to figure out the area of the rectangle, it's good enough for us to do the area of the triangle, right? If we can figure that out, then we just need to double it and figure out the area of the triangle. So, okay, so find the area of the triangle. Okay, so let's find the area of the triangle. So, okay, I have a triangle. I know two sides, and I also know that this is a right angle. So we could try to figure out base times height, and we could maybe figure that out, but it would use some kind of trigonometry, and it wouldn't be that easy to do. So there is a better way here. And so one hint is whenever you see a right angle triangle and you're given two sides, you should always figure out the third side, right? The third side usually has some information that you need. Okay, so what is going to be, how do we figure out the third side of this triangle? So let me call it X. So how do we figure out X?
I think if it's 90 degree, you use the Pythagorean theory, right?
Exactly, right? Very good. So what equation do we set up with the Pythagorean theorem?
So that will be this.
Mm-hmm. So how does the equation get set up?
So
So
now we use the Pythagorean theory.
yeah, so use Pythagorean theorem. So what's the equation that we get from Pythagorean theorem for this triangle?
Looking at the diagram, DE will be equal to 3 centimeters.
Right. So yes, we have c squared equals a
Then
squared plus b squared, but we're trying to solve for x. So what's the actual values that we plug in here?
3 squared
Yeah, 3 squared.
plus
Hmm.
the S squared
Exactly.
equal to
Right, equals square root of 10 squared. Right, and so this is pretty easy to solve. This is 9 plus x squared equals 10, which gives us x squared equals 1, which gives us x equals 1. Right, so we're going to get 1 over here for this side of the triangle. Okay, great, perfect. Thank you, Francis.
now we have to find the area of the triangle DEC, right?
Yeah. So area of triangle
So
DEC is what? Now that we know that these are right angled triangle with sides 3 and 1 here.
height and base and the height.
Exactly. And so what's the base and what's the height here?
The base would be half times 3 times 1.
Exactly.
It will give us 1.5 centimeters squared.
Right, exactly. So the trick here is you don't want to think of this root 10 as the base, even though it's a horizontal line. Since it's a right angle triangle, you can think of 3 as the base and 1 as the height, or you can think of 1 as the base and 3 as the height, right? Because if you spun this around, if you did spinning this around, it would exactly have, x equals 1 on the bottom and x and the 3 side would be pointing straight up. So exactly. So you get this is 3 halves. And so the area of the rectangle ABCD is 2 times 3 halves, which in this case is 3. Okay, so that's the answer here. So you have to do this in a few steps, but none of the steps is using a complicated formula, right? What formulas do we have? We have Pythagoras theorem to get this. We have area of a triangle, and we have area of a rectangle. Okay, those are the only formulas. But in order to figure it out, you need to be a little bit clever. And so what's my advice for generally doing these geometry problems? First, always draw a picture. Then, if you have a right triangle anywhere and you know what two sides are, it's almost always a good idea to use the Pythagorean theorem to figure out the third side. And then once you do all that, usually you will then have enough information to get the quantity that you want. So it's asking you for an area. Well, the fact that they had you draw this triangle can't be an accident. So that makes you want to think, okay, how does this triangle relate to the rectangle? And if you think about the area, you say, oh, well, the area of the triangle is half the area of the rectangle. Okay, so then you can just figure out the area of the triangle and you know enough information about the triangle to do that well. Okay. All right. Any questions on this?
Then
No.
we also calculate.
Okay. Good. Okay.
Then we
So,
also find the
so
height.
sorry, James. Sorry.
Yeah. Then we also find the height of the rectangle AD or the BC.
Right. So we could find the height of the rectangle. I mean, now that we know that the area is 3, it turns out that means the height is going to have to be 3 divided by square root of 10. So we could figure that out, but we don't have to. And it's probably not the easiest way to do the problem. Because if you want to figure out the height of the rectangle on the way to calculating the area, you're going to have to use some trigonometry and some similar triangles. So I think it's more difficult than just using the basic formulas here in order to get the area. Once we know the area, then of course the height is going to be 3 divided by square root of 10, because we know that when we multiply it by square root of 10, it has to give us 3. But I think just trying to actually figure out the height by yourself, that it's 3 divided by square root of 10, is not that easy. You're going to have to use a little bit of trigonometry.
All right.
Okay. All right, other questions? Okay. So let's move on, okay? Okay. So these are the questions from yesterday that we didn't get a chance to finish. Okay, so we're now done. We're done with all these questions from yesterday. So now I want to just go back and look at strategies. So for algebra questions, following techniques are often useful for solving the algebra questions on the Wits Math competition. So our general Kesca for word problems, there will always, always, always be at least 2 or 3 questions on the WMC that can be solved this way. Solving systems of equations by substitution, basic identities such as a squared minus b squared equals a minus b times a plus b, and then taking advantage of answer choices. We didn't really talk about this yet, so will be discussed. In our next examples. Okay, so this should be good enough to get fairly far on most of the algebra questions. The solving by substitution is generally good because anytime it's not just linear equations that you can easily do by elimination, then substitution is usually the best way. It's the most versatile way if you have a system of equations that you need to solve. Okay. What are some arithmetic techniques that are useful for solving questions on the AMC? So cancellation, this is big. So this is whenever a problem looks like a long computation. Right? None of the problems on the WMC are ever really supposed to be a long computation. Okay? So we have cancellation here whenever that happens. Shortcuts for computing things, shortcuts for counting things. If you remember last week, this is what we did when we were counting how many pages the diary needed to be in order to have 195 numbers written. So shortcuts for counting things, you don't want to count them all together. You want to see if you can group them somehow. Calculating the number of factors of a number. This is something that we talked about in the workshop maybe 2 years ago. Let me just review this because it's a kind of thing that comes out. So if a number n has a prime factorization of the form, let's say, p1 to the a1 times p2 to the a2 up through pr to the ar, then n has a1 plus 1 times a2 plus 1 all the way up to ar plus 1 factors. Okay, so this is a theorem. I'm not going to prove it, but it's a good result to know. And then we did prove it a couple of years ago when we did this. So just example. So if I take the number 100, 100 is equal to 2 times 2 times 5 times 5. Or in other words, 2 squared times 5 squared. So it has How many factors? Well, we just look at the exponents and we add 1 to each of them and multiply them. So it has 2 plus 1 times 2 plus 1, which is equal to 9 factors. If you want, you can check it by writing it down. The factors are 1, 2, 4, 5, 10, 20, 25, 50, and 100. And there's 9 of them. But if you just want to know the number of factors, you can use this shortcut formula. And this is a kind of thing that also seems to show up a lot on this competition to know how to do this. So if you want to know how many factors a number has, you can factor it into primes, and then you add up one more than all the product of one more than all of the exponents that appear. And if you do that, you get the total number of factors. Okay. So this is a kind of thing that shows up in a lot of arithmetic questions. We'll see an answer. We'll see a question like this in a little bit. Keeping track of the last digit, a kind of thing that happens a lot. This is what's sometimes called arithmetic mod 10. But know that to understand, or I won't say to understand, I'll just say to calculate last digit of an addition problem, a multiplication problem, or a subtraction problem, it's enough to know the last digits of the inputs. Okay, so this is sometimes going to be useful. We'll see an example where this is true. And then the last thing, just like for the algebra questions, taking advantage of answer choices, right? So we'll see again in a couple of examples, all these questions are multiple choice. So sometimes even if you don't know how to do the problem by itself, you can use the answer choices to your advantage. Okay, so we'll see a way to do that. Okay, so these are all different things that show up in the kind of arithmetic questions that show up on the WMC. Any questions here? Okay. Okay, so let's look at geometry techniques also. Basic perimeter, area, perimeter, and circumference formulas. Really, you only need this for squares, rectangles, triangles, and circles. Okay, so nothing too serious. Pythagorean theorem, right? This one we know. We have our right triangle here with a, b, c. Then you have that a squared plus b squared equals c squared. This will come up a lot. And then lastly, drawing a well-placed line. So we may see an example of this. There are times when drawing a line is going to help you there. Throw a light on the second one. Sorry, second one, you mean back here? Under arithmetic or under geometry? Under arithmetic. So we'll see this in an example, but this is like this example we did last week with the diary. So for instance, if you want to know how many digits are in all of the 4-digit numbers, instead of counting them, you try to figure out how many 4-digit numbers are there, and then the number of digits is going to be that multiplied by 4. So I just mean, using multiplication, for instance, to count things instead of adding them all up. Okay, it's just a kind of thing that happens in a lot of the questions. Okay. Okay. All right, drawing a well-placed line, and maybe I'm going to add a fourth one that I forgot to write here, but always draw a diagram if one is not given to you. And always draw a diagram if one's not given to you. Okay, so I want to go through just a few more practice questions that aren't going to be all in one group. Yeah, just go through a few more practice questions so that we can see, we can decide which technique is going to be useful for which type of question. Okay. Okay, practice question one. 12 friends met up at a bakery. On average, they ate 1.5 muffins. None of them ate more than 2 muffins, and 2 ate nothing. How many of them ate 2 muffins? And here I'm going to give you the answer choices for the multiple choice. So the answer choices are 0, 2, 4, 6, and 8. Okay? So I'm going to go, there's kind of 2 ways to do this. One of which is using the answer choices and one of which is not. So 2 ways. Okay? So one way is just the standard, this is a word problem. And what do we have? Well, if none of them ate more than 2 muffins, and we know that 2 ate nothing, the only variable is how many ate 1 and how many ate 2. Right? So let me just do this the fast way. I could do one way, you could do this with just Keska, right? And you could say, well, let X, we want to know that's the number, be the number who ate 2 muffins. Who ate 2 muffins. And then everybody else, well, 2 of them ate nothing, and the rest of them all ate 1 muffin. So if there's 12 friends total, then how many ate 1 muffin? Well, there's 12 friends total, minus the 2 who ate nothing, minus the X who ate 2, then this number ate 1 muffin. Keep writing F, ate 1 muffin. Right, because this here is the total, and this is the number who ate 0, and this is the number who ate 2. Right? Okay. And so if we have 12 friends who on average ate 1.5 muffins, so then if this is, sorry, James?
So that's 1.5, that is it.
Right, exactly. Yeah. So then what do we have for our equation? Well, the total muffins is equal to, 1.5 on average times 12, right? Because it's 12 people. But at the same time, that's equal to, well, the number who ate 1 muffin, which is 12 minus 2 minus X, times 1, plus the number of people who ate 2 muffins times 2. So it's going to be plus 2X, right? Because this is the total muffins eaten by people who ate 2 muffins, and this is the total muffins eaten by those who ate 1 muffin, right? So now we can just use algebra and figure this out. This is 18 equals 10 minus X plus 2X. And then you can solve this if you want. That's 18 equals 10 plus X. And this we solve very easily with 8 equals X. Okay, so this is just the kind of classic way to solve this question. Okay, this showed up on it. All these questions are from old WMCs. So the classic way would be to set up a word problem. And then if you want to, you can check. You can say, okay, well, if 8 people ate 2 muffins, and that means that 2 people ate 1 muffin, so that's a total of 18 muffins. That's right. Okay, I'm not going to write down the check here. But another way to do this, you can tell your students, maybe they forget how to do Keska. Maybe they forgot how to set up a word problem. Maybe they're confused about how to set it up. Well, there's only 5 answer choices. So in this case, you can just check each one and to see which ones work, right? So the second way is to just check all the choices. And there aren't that many choices, so this isn't that hard to do, right? So if you want to check all the choices, 0 would be 0 times 2 muffins. And if nobody ate 2 muffins, then there's going to be 10 who ate 1 muffin. So plus 10 times 1 muffin. Well, this is equal to 10. That's no good. That would be the 0 choice. Now, what if 2 people ate 2 muffins? You'd have 2 times 2. That would mean only 8 people could eat 1 muffin. That's going to be equal to 12. That's no good. You could have 4 times 2. These are all the answer choices. I'm underlining the answer choices. If 4 people ate 2 muffins, that means 6 of them ate 1 muffin. That's going to give you 14. That's no good. If 6 people ate 2 muffins, that means 4 of them ate 1 muffin. That's 16. That's no good. But if 8 people ate 2 muffins, then that means that only 2 people ate 1 muffin, and that gives you 18. And this is what you want, right? This is the correct total. Okay, so right, this over here gives you the correct total. Okay, and so that means that this 8 over here is the correct answer. Okay, so if you don't want to set up the algebra and everything, you can just try each answer choice to see which one gives you the right answer, right? And there's only 5 answer choices, so you won't actually lose too much time by doing that. Okay, so this is important to tell your students. If they can't figure it out, I mean, of course, they can take a random guess. But if instead of doing a random guess, they can just try each answer choice until they find the right one, then that's better than taking a random guess. And that usually gets done faster. Okay, and certainly it's more accurate. Okay. All right. Any questions on this? Okay, so we have 2 different solutions here. We have the algebra solution and we have a trial and error solution. Okay. Great. Okay. Practice question 2. 64 identical circles are each inscribed in separate squares with a perimeter of 1. What is the total area covered by all these circles? Okay, so if you've been listening, you know what is the first thing that you have to do for this problem before you do anything else. Well, you've got to draw a diagram, right? This is a question about geometry. You got to draw a diagram. Okay, there's no diagram given to you, so you have to start with that. So I'm not going to draw a diagram with 64 circles. That's going to take too long. The 64 doesn't even matter that much to this question. It's just 64 copies of the same thing. But I definitely have to draw 1 circle in 1 square, right? So we have a circle inscribed in a square. So this is our square. Let me redraw this so that it looks more like a square. So let me actually draw my circle first. So circle, and then I'm going to inscribe this in a square. No. Sorry. That's a little better. Okay, so there's my circle inscribed in a square. Okay, so what do we know about this? We know that each square has a perimeter of 1. So if the square has a perimeter of 1, how long is each of its sides? Well, the square is perimeter 1, right? It has 4 sides, right? So each side of the square has length 1 over 4, right? I mean, that's what a square is. It's got 4 equal sides, right? So if its perimeter is 1, then each of the side lengths is 1 over 4. Okay. Well, so what do we want to know? We want to know the area of, well, it's asking the total area of all the circles, but these are 64 identical circles. So it's really good enough to know the area of one circle, and then we can just multiply it by 64 at the end. Okay? So if we want to figure out the area of this circle, well, we need to know the formula for the area of a circle, right? Remember, so I'll just write that down. Remember, area of a circle is pi r squared, where r is the radius. But now we also need to know what the radius of this circle is. So what is the radius of the circle? What's the radius of the circle?
Radius of that circle
Yes.
Mm-hmm. I think James is first.
So
Yeah,
Honorable.
Princeton? Yeah.
So the radius of the circle will be equal to R will be equal to D over 2.
Right. So it's going to be the diameter over 2. And what's the diameter of this circle? Given that it's inscribed in this square where every side is 1/4.
The diameter is the total.
Right. So what is it? What's the number? What is the radius of or the diameter of this circle? I claim you can get it from the diagram, and it's a number, not just a letter, right? So what is the diameter of this circle?
So the diameter is the total distance. So let me say the length that is divide the circle into 2. So now looking at this, we have the
So if it's a diameter, I guess we could draw the whole line if we want. And so how long is this line? What's its length?
Are you asking for the radius of the diameter?
No. Can we say?
So what's the length? Just tell me. There is one number that is the correct length of this line. So what number is it?
So can we say 1 over 4?
Yeah, it's 1 over 4, right? This line is the same as the side length of the square, right? These lines are the same. Right, yeah. So the diameter is so we can say the diameter equals 1/4. So the radius is equal to the diameter divided by 2. And that's 1/4 divided by 2. That's going to be 1 over 8. Great. So the radius is 1 over 8. That's great. So the area is equal to pi times 1 over 8 squared, or in other words, pi divided by 64. Right? So that's the area of one circle. So now they're saying 64 identical circles, and they want to know the total area. So you don't want to forget the last step. So another technique, which is always useful for every type of question, is make sure you answer what the question is asking, right? So you might stop here and say, okay, pi over 64, I'm done. But you have to remember the question is not asking about one circle, it's asking about 64 circles, right? So this is the area for one circle. Yep.
So there are identical circles.
Right.
The total area would be or different.
Exactly, right. It would be 64 times pi over 64. And that is going to be equal to pi. Okay, so that's the correct answer here, is pi. Okay, so the final answer here is pi, right? And so again, remember, there's no complicated geometry formulas here, just the area of a circle, perimeter of a square, basic formulas, but you have to do it step by step and be careful about how it's done, right? You've got to draw your diagram, then you know that you're trying to figure out the area of a circle, so you have to know the formula for the area of a circle. And then you have to figure out what is the input, what is the radius. So you have to use this diagram to figure out what is the radius of this circle. That radius is going to be 1/8. Then you can plug that into the formula, and then you can use that to figure out the actual question that's being asked. Okay, so there's a lot of steps, and even though this question is not that hard, but there's a lot of different steps, and if you forget any one of the steps, then you're not going to get the right answer. So it's important to tell your students to make sure that they're being very careful and doing every step and really coming up with the answer to what the question is asking. Because a lot of times people will go too fast and they won't actually answer the question that's being asked. So you need to make sure that they're careful. Okay, any questions? Okay. All right, let's move on. Okay, so practice question 3. 4 squared equals 16 ends in a 6. 4 cubed equals 64 ends in a 4. What does 4 to the 2023 end in? Right, so this is an arithmetic question. And clearly the wrong thing to do, wrong thing is to try to actually calculate 4 to the 2023. Okay, clearly not going to work. Okay, so what's the right thing to do? Well, anytime we see a long computation, and this is not one where there's really going to be any cancellation because there's nothing to cancel. It's just a bunch of 4s and 4s. So what you need to do here is just look for a pattern. And remember, what are these things? 4 to the 4th, 2023 is just 4 times 4 times 4 times 4 all the way times 4, and you just do it 2023 times, right? And so one thing that I mentioned over here with the arithmetic questions is keeping track of the last digit, right? This is something that shows up a lot, keeping track of the last digit. And if we're calculating the last digit of an addition or subtraction or multiplication problem, in this case, exponentiation is really just a multiplication problem, it's enough to know the last digits of the inputs. Okay?
So we are
Yes.
using the power of both.
Sorry.
We're
No, here
using the power.
So James, sorry, I can't, I'm not getting you that clearly.
So we are using the power of both.
Yeah. So let's see the pattern, right? So
Yeah.
4 squared
Then
ends in 6, 4 cubed ends in 4. Okay, just rewriting what the question said. Okay. So what about 4 to the 4th?
we'll put the 256, 86.
I'm sorry, I'm not getting you so clearly.
866. Get 256, 866.
Right, it's going to end in 6. Exactly, right? Because this 4 is just 4, and 4 cubed ends in 4. And so to know what the last digit, well, whatever this thing is, it ends in the last digit of 4 times 4, which is 6. Okay, so 4 to the 4th is going to end in a 6. In fact, it's 256. Right? And carrying on, 4 to the 5th. Sorry, yes?
The last digit follows a repeating cycle 4 to 6.
Exactly. It's just going
Wow,
to go
yeah.
back and forth between 4 and 6. So, right, this is 4, and this ends in a 6, which we've already seen. And so that means the last thing, it ends in the last digit of 4 times 6, which is 4. Okay, so now we see the pattern, and you don't have to prove it because it's a multiple choice exam. It's not for proofs, but we see that we've got 6. As James said, we have a pattern. 6, then 4, then 6, then 4, and so on. So this is the pattern. 6, 4, 6, 4, 6, 4, so on. Right? And what is this? This is 4 squared, 4 cubed, 4 to the 4th, 4 to the 5th, 4 to the 6th, and 4 to the 7th. All right, so where is 4 to the 2023? Where is that going to show up? Is it going to be a 6 or a 4?
Hello.
Yep, hello, yeah. So it's going to be a 6 or a 4?
Then the exponent 2023 is an odd number.
Right.
It is so the 4 to the 2023.
Right. So we see, right, all of the odd ones end in 4s. Right? 4 cubed ends in a 4, 4 to the 5th ends in a 4, and 4 to the 7th ends in a 4. So all of these odd numbers end in a 4. 2023 is also an odd number, so this is going to end in a 4. Okay, so that's the answer. Okay, so we find a pattern, and then once you find the pattern, then you see that it just alternates 6, 4, 6, 4. Then you just need to check, is 2023 even or odd? In this case, it's odd, so that means the total thing there is going to end in a 4. Okay, so this is arithmetic question, how this would be approached. Okay, and of course, you don't need to do any complicated computation, right? You just need to establish this pattern 6464, which is based on the last digit. Okay. All right, any questions on this? Okay, let's move on. I think we have time for, we have 2 more questions. So practice question 4. What is the smallest natural number that has exactly 6 positive factors, exactly 3 of which are odd and 3 of which are even? So here are the answer choices. 1, 8, 12, 18, and 24. So this is one of these questions where you could just do this without the answer choices, but I think for a question like this, it's going to be much easier and much faster to just try all the answer choices. So yeah, before you start a question, before your students start a question, you want to say, is there a way to just use the answer choices to get the answer correctly and quickly? And in this question, I would say definitely the fastest way is just try all the answer choices. right? So if I have a number, this is my number, and this is all its factors, right? There's only 5 numbers that we have to check, right? So we got 1, 8, 12, 18, and 24. We want to know exactly 6 positive factors. Okay, so 1, that's ridiculous. The only factor is 1. Certainly not going to be the answer. 8, the only factors are 1, 2, 4, and 8. That's not 6 positive factors. 12, what are the positive factors? We've got 1, 2, 3, 4, 6, and 12. You can just count them. These numbers are small enough. But it says we need that 6 factors, but we need 3 odd and 3 even. And in this case, only 2 of them are odd and 4 of them are even, right? 2 odd, 4 even. So that can't be the right answer. Now, what about 18? You have 1, 3, 6, 9. Oh, sorry, 1, 2, 3, 6, 9, and 18, right? So all the factors, make sure you don't forget any. 1, 2, 3, 6, 9, and 18. Okay, that's also 6 factors. And are there 3 odd and 3 even? Well, 1, 3, and 9 are odd, and 2, 6, and 18 are even. So this one is right. 3 odd, 3 even. So this has, yeah, so James is right. So this is the answer. And we don't even need to check 24, right? Because it's asking for the smallest one. You've already found the smallest one. Maybe 24 has 3 odd and 3 even factors. In fact, it doesn't. But even if it did, it wouldn't be the smallest because you've already checked 18. So here for this 24, you don't even need to check this one, because you know that one of the answers is going to be right. In this case, the correct answer, I don't know why this link is here. In this case, the correct answer is your 18. Okay, so for this type of question where it's asking you to do a really short, kind of easy computation with small numbers, best thing to do is just try all the answer choices. Okay? I should link this to what we said about the factors of numbers. Remember, 18, we can write it as 2 times 3 times 3. This is how it factors into prime numbers, which is equal to 2 to the 1 times 3 squared. So the number of factors, let me make this a little bigger, right? So the number of factors, according to the old formula, this is equal to 1 plus 1 times 2 plus 1, right? Remember, we add 1 to each of these exponents and multiply them together, and that's 2 times 3. That's going to be 6, right? That's exactly what we... But the point is 18 is small enough that we don't even need to do this, right? Because 18 is small enough that you can just write out all the factors. It's not that hard to do, right? So... yeah. So, okay. So in this case, you just want to check the answer choices. It's going to be easier than doing it any other way. Okay. So yeah, tell your students if it's easier to just try all the answer choices, that's worth doing. And I think in this case, using the answer choices is actually faster than doing it any other way. Okay. Questions here? Okay, so let's do the last question. Okay, so practice question 5. If someone stands on an escalator, it takes 50 seconds to get from one floor to the next. If the escalator is not working, it takes Coco 75 seconds to walk up the same escalator. How long will it take Coco if she walks up the escalator while it is working? Okay, so this is the hardest of the ones that we've done so far. And it gives some answer choices: 15, 25, 30, 40, or 125 seconds. Okay, so the first thing, before you even do this, you know that the escalator only takes 50 seconds, even if you just stand on it. So if you're walking up it while it's working, that's going to be faster than just standing on the escalator, right? You're walking up and it's working. So whatever the answer is, it's got to be faster than 50 seconds, right? So in particular, you can eliminate this last choice. This 125 is ridiculous, right? Whatever the answer is, has got to be faster than 50 seconds. So you can eliminate 125 at the start because walking plus escalator is faster than walking or escalator alone. Okay, so this 125 seconds is ridiculous. And some people will give this answer because they'll look at the problem and they'll say, "Oh, this is a word problem. I don't understand how to do it, but I see the number 50 and I see the number 75, so maybe the answer is 50 plus 75." And that's why they're going to write down 125 seconds. Whereas if you think about this, even if you don't know how to do the problem, even if you don't know how to do the algebra, you should be able to look from the beginning and see that 125 seconds is obviously and clearly wrong. Maybe not as clear to figure out what's the right answer, but 125 seconds is a ridiculous answer. It's completely wrong. Okay? Because it's got to be less than 50 and it's got to be less than 75 because there's standing on the escalator or there's walking up the broken escalator. When you're standing and walking, you're going even faster. So it's got to be faster than 50 seconds. Okay? All right. So this is so you can't do this. Okay, so eliminate the 125, but I guarantee you lots of students will write 125 as their answer because they'll just see the 50 and the 75 and they'll think, okay, maybe I should add them, and that's the answer. But of course, that's not doing math. That's just looking at numbers and not paying any attention to what the problem actually says, right? So we know now if we want to do a word problem like this, we've got to set it up with Casca, right? And so these rate problems are sometimes a little bit tricky. Okay. So in this case, actually, yeah, does anybody have an idea how to set it up? This question's not that easy. It's easy to see that 125 is wrong, but it's not as easy to see which of these other answer choices is correct. So does anybody have an idea of how we can maybe set up an equation to get this answer?
Hello.
Hello, yeah, James?
Yeah, we need to identify the individual speed first.
Mm-hmm. Yes, we got the data.
The escalator.
Mm-hmm.
It's just a conversion. The speed was the same for that escalator.
Right. So with the D, yeah. So I think I'm not sure if I got you correctly, but let D be the distance of the escalator.
Yeah.
Okay, great. Yep. Okay, so D is going to be the distance of the escalator. And remember, we're not really trying to solve for D. We're trying to solve for how long will it take Coco to walk up the escalator when it is working. So, okay, so D is the distance of the escalator. So escalator speed is what? Well, the speed is the distance divided by the time, which is equal to D over 50, right? Oh, sorry, D over 50, right? That's the escalator speed, right? Because you just stand on the escalator, takes 50 seconds. So what's Coco's speed? Well, again, it's distance over time. So this is just Coco's plain walking speed. So yeah, James, what does this come to?
is 4. Will you add the 2D
D over,
and the 4?
great, perfect. So D over 75. And so now we want Coco plus escalator speed. Well, that's their sum. And so that's their speed together, right? So if the escalator by itself is D over 50, Coco by herself is D over 75, Coco with the escalator is D over 50 plus D over 75. So now the question is asking, right, how long will it take Coco if she walks up the escalator and the escalator is working, right? So that means she's going at this speed. So the time when walking plus escalator working is, so what's that going to be?
First from that session, then we'll find that.
Mm-hmm. Yeah, right. So it's the time is going to be the distance divided by the speed, right? So that's D. And the speed we already wrote, right? D over 50 plus D over 75. Okay. So I don't have enough space. So let me put this on a new page. So we have D over 50 plus D over 75. All right. How are we going to simplify this?
Well, that means common factor.
So what's a common denominator for 50 and 75?
150.
150, exactly. All right, so we get 3D over 150 plus 2D over 150, right? This is the common denominator. Okay.
5D was.
Great. 5D, exactly. D over 5D over 150, or another way of writing that is D over 30.
Yeah.
And how does that simplify?
I have a calculated time.
Right. D
This
times.
time what?
Right.
The answer is that is 30.
Exactly. So the answer is 30 seconds. Okay, so this here is just simplifying. The real work is what's on the previous page. So the answer is 30 seconds. So we'll see. So we have that. That's one of our answer choices. Definitely not 125 seconds. And so the point, though, is in order to figure out this time, we need a distance. And you don't know what the distance is. You just have to call it a letter. You just have to call it D. And then you need to know what the total speed is. And in order to figure out the total speed, you need to know the individual speeds leading up to the total. Okay? So this is a harder question. I would say this is definitely from the second half of the WMC. And it ends up just being a standard Kesko word problem, but you have to be careful with how you set it up, and you have to not just look at the numbers and say, okay, what can I do with 50 and 75 to make an answer? Because from 50 and 75, you're not going to come up with 30 in your mind. That's not 75 minus 50 or 75 plus 50. It's just a number 30 that comes out when you do the problem, right? So students, when they have a word problem, they need to make sure they actually read the problem and really write down what the variables are and try to answer the question that's given. Okay, and if they can't do that, at the very least, it's better to eliminate 125 so that when you guess, you now have a 1 in 4 chance instead of a 1 in 5 chance. So the odds are a little bit better if you realize that 125 is a bad guess. And even if you have to guess, you can guess from fewer choices. Okay, so that makes it a little better. Okay, any questions here? Okay, so I think that's all for the practice questions for today. So thank you for your attention and good luck to everybody who's coaching a team for the WMC. So we're not going to have another meeting before that happens. So actually, our next meeting again is May 21st. So yeah, so May 7th, I'm traveling, and then May 14th is we're not going to meet. It's Unification Day. So we'll meet again May 21st. That'll be our next meeting, so we're skipping 2 weeks. And we're going to change gears a little bit. I'm going to talk a little bit about some of the technology that I use for creating presentations. How do I make these slides? How do I display math in the slides? How do I get pictures and everything like that? So I'm going to talk a little bit about how to do this. And the of course, all of this is getting easier because with artificial intelligence, at this point, if you can use ChatGPT to draw these things in a way that, I have not, done for most of my career. So I'm going to talk a little bit about how AI can make learning some of these things a little bit easier. But for now, yeah, so we'll be switching gears a little bit. It'll be more of a technology and presentation kind of workshop. Okay, but in between now and then, the students are gonna take the WMC. So I wish good luck to the students and good luck to all of you. And yeah, thank you for your attention as always, and I'll see you in 3 weeks. And happy to take any last questions. Okay, last chance to write your name down, and then I'm gonna stop the recording. Okay.